evening everyone. So myself Gautam Sharma, I welcome you all in a seconds education. So today I am going to discuss about the angular momentum and its relation with the torque. So what actually angular momentum is and what is the relation between angular momentum and torque. So previously I have completed this all this topic. So yeah, okay. Now what is angular momentum, right? See. Angular momentum Angular momentum of a body about a given axis is the product of its linear momentum and the perpendicular distance. See here, let's consider this an object is moving in a circular motion. So it has some linear velocity, that is v, okay, linear velocity v, and the distance between this about which this object is moving is perpendicular distance. Okay, see here. Linear momentum L can be written as linear momentum into perpendicular distance. What is linear momentum? Suppose this has a velocity v, so linear momentum is your mass into velocity and perpendicular distance of the line of action of the linear momentum. What is perpendicular distance of the line of action of the linear momentum? See, try to understand from this figure. Let us consider there is an object, okay, and this is a point about which an object is being rotated, and the force with which it is being rotated is F. So what is the line of action of this force? This is the line of action of force. And if I will talk about the perpendicular distance, so this is the perpendicular distance. So whenever we want to multiply it, always multiply with the perpendicular distance from the point about which an object is being rotated and the line of action of force. A force may be like this, right? Force may be like this. So what is the perpendicular distance? So this will be the perpendicular distance. Understood? So this things you should understand. So finally, perpendicular distance. So if this is your theta, see here, if this is a angle 90 degree and this is your angle theta, so can we write here L is equal to mvr sine theta? I hope you have understood, or again I am making you understand. See here, this is simple example. This is a simple example. You take this as a point, okay, and the line of action of force is this, okay. So the see here, this is distance r, but what is the perpendicular distance? So this is the perpendicular distance. So if the angle is theta, so finally we will get, can we get by substituting r sine theta by using this method? See, suppose this is your angle theta and this is the r, so can we get like this sine r sine theta? So this is the perpendicular distance. So L can be written as mvr sine theta, okay. L can be written as mvr into sine theta. That is, can we write here L is equal to m r cross v, okay. So if r, since r is constant, so m into v is your momentum. So can we write here linear angular momentum is equal to r cross linear momentum. So this is the formula. What is the unit? Unit will be joule, and the dimension is your m l square t minus 1, okay. So I hope you have understood now. Now see here, what is the direction of the angular direction? See, direction can be found out by right hand thumb rule. See here, this is your linear velocity, this is a r, and so direction will be upward. Angular momentum direction will be upward. See here, if it will rotate, so when you will rotate any type of screw, so it will go up. So this is the angle. I hope you have understood now, okay. Okay, so this is the direction will be upward or direction will be downward. So directions are upward or downward. Understood? So that is axial direction of angular momentum is your axial direction. See here, angular momentum is an axial vector and its direction is given by right hand screw rule. So right hand screw rule, you have to use right hand. So you, if you will place a thumb, if you will do cross like this, R cross. See, if you will do R cross P, so you will get the direction upward direction. Okay. So angular momentum has the direction of angular momentum is your R cross P using right hand thumb rule, or using, you can say that it is a vector product also. By using vector product, you will get the direction. Okay. So finally we are getting angular acceleration in upward direction, that is alpha, angular velocity in upward direction, angular momentum, that is L, is in upward direction. So finally you have understood the gist of the angular momentum. I hope you have understood now. Now let us consider relation between torque and the angular momentum. So we have already derived this angular momentum L as R cross P. Now differentiate it with respect to time. We can get that dl by dt is equal to this. Suppose r is the r you have kept in a bracket, and dp by dt plus dr by dt across r. By using uv method, by using differentiation of differentiation of u into v method. Okay. So by using uv method, so can we write here dp, rate of change of momentum, linear momentum is force, and rate of change of dr by dt is known as velocity, and p is your mv. So tell me, velocity cross mv. See, linear, see here, velocity, mass is your constant, v cross m, v will be 0. Why? Because the angle between v and v is 0, and v cross v means v m into mv sine 0 degree. So sine 0 has 0 value, so this part you will get 0. So finally we are getting r cross f plus m v cross v. So this is a 0, so r cross f. So what is actually r cross f? See here, dl by dt into r cross f. So we have already discussed torque is equal to r cross f, r cross f. So r cross f can be written as torque. So we can write here rate of change of angular momentum is equal to torque applied on it, torque, net torque applied on it. Yes, we can write here. So if any body is there and it is being rotated or not rotated, we don't know, but if you will apply a net torque, so its angular momentum will change. Rate of change of angular momentum is equal to torque. It is similar to rate of change of linear momentum. We have studied that rate of change of linear momentum is your force. So similarly, rate of change of angular momentum can be written as a torque. Okay. So law of conservation of momentum. Now we will discuss about law of conservation of momentum. So if the resultant torque acting on a body is 0, if the resultant torque acting on a body is 0, okay, resultant torque acting on a body is 0. It means that, for example, this is a body, okay, I am applying a torque like 10 Newton meter in this direction, and in this direction also 10 Newton meter in opposite direction. So both, if you will add them, so 10 plus 10 Newton meter minus 10 Newton meter, so finally we will get 0. We will get 0. Okay. So this is the net. So if the resultant torque or net torque acting on a body is 0, then the total angular momentum of the system will remain constant. Okay. Because torque is equal to dl by dt. If torque is 0, net torque is 0, so dl by dt is 0. So dl by dt is 0 means what? L is constant. Because if you will differentiate any constant terms, so you will get 0. So this means that L will remain constant. That is, final angular momentum is equal to initial angular momentum. I hope you have understood this section. So I hope you have understood this. Now I will talk about equilibrium of a rigid bodies. What is equilibrium of a rigid bodies? A rigid body is said to be in equilibrium, mechanical equilibrium, if its linear momentum and angular momentum is not changing, or we can say that body has neither linear or nor angular acceleration. Linear momentum is constant. Angular momentum is constant. Linear momentum is your constant. Then body is said to be in equilibrium. Body is said to be in equilibrium. So for equilibrium condition, so can we write here for equilibrium? For equilibrium, total force should be equal to 0 and total torque should be equal to 0. Why I am talking about total force? See here, if force will be 0, then angular momentum will be constant. Sorry. If force will be 0, then linear momentum will be constant. That is, P will be constant. And if torque will be 0, then it means that angular momentum will be constant. Understood? So for equilibrium condition, these two formula is very important. These two important formula is very important. Summation of total force is equal to 0 and summation of total torque is equal to 0. So if these two condition is being satisfied, then we can say that body is in mechanical body is in mechanical equilibrium. Body is in mechanical equilibrium. I hope you have understood now. Thank you. No, just wait. Okay. So see here. That is two condition must be satisfied. See here. F1, F2, F3 total F should be 0 and vector sum of the total torque should be equal to 0. That is torque 1, torque 2, torque 3, torque n. So total torque must be equal to 0. Now for today's video it's enough. Thank you.